Mirsad, and probably some of you already know me. So, long story short, I have been working as embedded software engineer and embedded system engineer for the past 6 years. And as my first experience, as a full-time first experience, I had a chance to work in Siemens in the Czech Republic, in the domain of creating devices for the automation, basically the motor controller used around the PLC. And then after that, I moved to the automotive, and for the 3.5 years, I've been working in Rimac, developing the basically BMS for the different cars. So I had a chance to be in team which developed basically the battery for Rimac Nevera, and then this new Porsche 911. It's basically GTS, Turbo S, and I had a chance to work as well as battery for Bugatti Tourbillon. After that, I moved into the domain of consulting, and right now I'm working on the projects in the battery energy storage system domain. Why I'm trying, today the idea is like to try to give you like crash course to requirement engineering. So basically it will nice fit with the things about which they didn't talk about. So, okay, what is really requirement engineering? So requirement engineering is a process of defining what system really shall do, and then writing that down in some kind of formalized form, so that everyone, including, stakeholders, designer, engineers, and your customers can understand it and be on the same page. Why it's so important? So, if you start developing your product, without your team being, aligned about the things which shall be achieved, everyone can start to pull, on developing different things, and, team will start losing focus. And for young engineers, usually one of the biggest trap is that you start developing something without really knowing what you are trying to develop. And that's why requirement engineering is so important. So here are some benefits of requirement engineering. So first one, you'll prevent loss of ideas and vision. So once you start developing your product, you'll have a bunch of great ideas. You'll communicate that with your teammates. And after a few days, you'll start forgetting things. That's the first issue. And after a few months, you will get the same idea, and start working on it, and then you'll forget it again, So that's why it's so important to, once you have the idea, to write it down and to have it stored somewhere. Usually, there are some tools, which can help you, like store requirements as JAMA, as IBM Doors. But the starting point, if you are a small company, you can use, Excel for such purpose. The next benefit is basically it helps you articulate your ideas and vision. So, it's really hard sometimes to explain to others what you are trying to achieve, without writing that down, without drawing some sketches. Maybe you will try to utilize, some kind of framework as UML, to try to draw some diagrams which will help you, show what you're really trying to achieve to everyone. Then, next thing, you will facilitate a clear understanding of what to build. So, as third one team to be, online what we are building, especially if you are working on a big project involving, mechanical engineers, software engineers, hardware engineers, maybe even some other high-level system engineers, you need to have something written down and be, in line with what you're trying to develop. And in the end, what is really important is defining deliverables. So if you're working for someone else, for customer which requires you to develop something, you really need to have something on paper which you will sign, and on what you will base your contract. So basically, you will define a list of requirements that your product, which you shall develop, which will you deliver shall implement, and then basically on that, people or other companies will pay you. So let's jump to what are requirements. So yeah, requirements are formal description of what product or system shall do and how it should behave. At a high level, requirements are most often stated in textual form, but that's not the only form. I mean, you can formalize requirements using the UML diagrams, use case diagrams. You can, use different kind of formats. Usually, people are doing that using some textual form. And for beginners, usually it's hard to articulate, how to write requirements in some consistent manner. So one example of the requirement is, I focus like the whole presentation about the power charger, but the first requirement is related to automotive. So while driver is performing very sudden braking, the car shall turn on hazard light instead of brake lights. May you see this feature on the new cars. So basically, if you are driving on the highway, someone will start to suddenly brake because there is car accident in front of you. Car will, instead of you, turn hazard light to, give notification to others behind you to start braking early. And another example of requirement is, for example, that one for the power charger. So all of us are using power chargers. Maybe we'll have a chance to design one. Power charger can be one for the mobile device power charger, but you can charge even the car. So, and one requirement could be like that. For example, if it overheats, the power charger shall cut out the power to the connected device. The requirement, which makes sense, requirements doesn't describe, at least at the high level, how things shall be implemented. Only things which shall be implemented, indeed. One of the biggest topics is how to organize requirements. So requirements are basically organized in some layered and hierarchical manner. So you will start with something which is very high level, for example, the requirement which I mentioned before, and then you will basically derive how that requirement shall be implemented. For example, if you want to cut out power to the connected device in the case of overheat, maybe you want to have some temperature sensors which will monitor the temperature. You want to have some MOSFET which can cut out the power in between the power conversion stage and the output. And for example, you'll have a requirement that your MCU, once it detects that temperature on any of sensor is about 70 degrees, that it will basically switch off the power MOSFET to cut out the power. So you will start from the top level and then figure out how you will implement that. Yeah. May you see that all of the requirements which I wrote, follow some kind of form. And that's one of the most important topics, to have requirements written, in some kind of consistent syntax. And that's why I want to talk about requirement syntax. So usually all requirements are written in some form that you will state name of the system, shell, and then do something. But what I found out working on some previous project is this easy approach to requirement syntax. Basically, it's invented by the guys working in the Rolls-Royce. Rolls-Royce is not only making cars, they're making aircraft engines. And they figure out, very simple set of syntax, which they are using on all of their projects. And I saw this, standard of writing requirements being, implemented by many big companies automotive, including Volkswagen and Porsche as well. So, and I want to go, through it and using some, examples. So, easy approach requirement syntax basically has 6 different type of requirements. So first one is ubiquitous requirement. That's requirement which is basically applicable in all cases, all scenarios. So let's say for the power charger, ubiquitous requirement is that it shall provide a stable 5-volt output voltage. So in all cases, that shall be true. But apart from the ubiquitous requirements, you want some features to be applicable only in certain scenario, and there's a reason why there are state-driven requirements. And easy approach to requirement syntax has a special form for it. So if you want to have something that is state-driven, you will use this form like while, precondition, the system name, shell, and then system response. And then an example on the power charger is this, that while no device is connected, for example, power charger shall not consume no more than 10 milliwatts of power. So yeah, you really don't want your power charger to waste a bunch of power in the end. Maybe for some bigger chargers for car, the numbers will be higher. But in principle, this is like requirement applicable to all power chargers in the end. The next type of requirement is event-driven one. So basically, instead of applying to the state, there are some requirements which shall be triggered when some special event occurs. And for example, for power charger, when a device with low power impedance is connected, power charger shall ensure that no surge in output current will occur. So why it's so important? Basically, once you connect something with a low impedance to a power charger, you don't want device to be blown by big current in the end. And basically, this kind of this easy approach requirement syntax help you state everything in this kind of nice kind of formalized form. Next type of requirement is unwanted behavior requirements. So all of the previous requirements are only applicable for positive case scenarios. So when everything is happy, no error in system is occurring, those ones are applicable. Unwanted behavior requirements are specifically designed to to state that something shall happen in the case of error. And in the case, for example, using the power charger, let's say that if short circuit occurs in the power conversion stage for I don't know any reason, the power charger shall blow the fuse on its input line. So makes sense, to protect your power charger, to flame itself up. And yeah, the last two type of requirements is basically complex requirement, which is merge of everything before. So usually, in most cases, you will have requirements like this. So it will compile event-driven, state-driven, maybe this negative case requirements. And one example of it is let's say while device connected, and when short sudden second surge in current or surge in voltage occurs, the power charger shall continue to normally provide power to connected device. Makes sense. You will connect your power charger, connect some device to your power charger, and you want it to continuously provide power, even if something suddenly and shortly happens on the grid. And the optional feature requirements, they are not usually used. Most often used. But yeah, I stated it there anywhere. So let's say optional feature is basically feature which is only included in the in certain version of your product. So let's say that you will have a type of product for each market, but you will have super duper version of product which will basically be which you can use on all the markets. So let's say that you want to have power charger which is compliant with EU, USA, and Japan standard, so that you can basically plug it in USA and it will not blow up because they are using different grid frequency or different voltage. In a car, for example, optional requirement is to have openable roof, for example. Then you can state that in the case where you have openable roof in the car, yeah, the car shall have a switch to open it or close it. There are some attributes of well-written requirements. So basically, requirement shall be singular. So one requirement shall only focus on one thing. That's it. Shall be clear. So once you read requirements, it shall be clear to you what the requirement is stating. So if requirement, like a good indication is that if requirement is too long, it's not clear. So, and in the end, you shall like separate it into multiple pieces. It should be consistent. So if you are, for example, using one measurement unit, let's say metric, you shall not, like in the middle of the project, move to the imperial units. And that happened indeed, like to NASA, one of their rovers. So basically different teams develop different pieces of software. And then the landing gear, program for landing gear was semi-written in imperial, semi-written in metric. And because of it, basically the rover, which worth like hundreds of millions, basically crashed into Mars instead of like a landing like neatly into it. Requirements shall be correct, shall be complete. I think that's self-explanatory. Shall be feasible. So once you are designing system, you can you can tell that you want a car which can run 600 kilometers per hour, but like taking into account all the current technology, probably that's not feasible, So you can require that, but if you can implement that, it doesn't make sense. Yeah, requirements shall be verifiable. So it doesn't make. It's like let's try to explain that. In most of cases, you can verify all the requirements. But the thing is, like, you shall take into account the cost. So if you want to design something, a car, let's say, which is 5 meters long, and if you want to like specify that the deviation is like 1 micrometer, it's very hard to verify that. Even when production, all production process can manufacture that car, you will need to have really special kind of equipment to measure everything. So such requirement is probably not verifiable or hardly verifiable. So like instead of specifying such small unit, probably it makes sense to give a bigger tolerance. And traceability, which is especially important for things about which Nadim talked about. So if you have some standard as medical one, which will be important for getting your product put in a certain market, you need you have traceability in between different, statements in the standard and the way on how you basically achieve that in your product. So at the end, there are some tips for, for some young engineers. So while you are developing your product at the very beginning, try to give some, bigger margins while designing requirements. So not try to specify everything within, 1 millimeter, 1%, etc. Give bigger tolerance, and then later through the project you can refine it. And another tip is you shall make difference in between requirements and specifications. So requirements specify what the product shall do, not how the things are implemented. And then specification is basically tells you how the requirement is achieved. For example, you are developing some gadget device, mobile phone, and the requirement shall be that you can fit it within jeans pocket, but dimensions can be different. But specifications, during development, you will figure out that dimensions which you can fit within your jeans pocket are the following one, and that they are also making sense because of the other requirements, and then you will choose to have these specific dimensions. So while designing your product, at the very beginning, during the requirements, definition stage, try to state what product shall do, and then later during the architecture design and engineering, you will figure out, all the details. That's it. Do you have questions?
Maybe I can start.
Okay, yes, sure.
Okay, I also come from one company that's dealing with a lot of projects with a lot of different clients. Is it possible to make like some kind of draft document which will be used for any project that we are working on? So you can send, because when we are starting project, the client doesn't know, maybe we are dealing with the client without, technical skills, and we ask them for the requirements and they say, okay, what do you want me to write there? Is there some possibility to make like some kind of draft document for that?
Ah, okay. I mean, it really depends on your industry. So if you are, focusing in one industry, I mean, you can have, preliminary set of requirements which you can showcase to your customer, and then like your customer can give you feedback if all of them are fitting or if something can be changed. But, if you are dealing with automotive, I mean, you cannot apply the same set of requirements to, I don't know, to battery energy storage system sector or something else. But for sure, if you are focusing one sector, you can have something, pre-developed. And usually it's like if you're dealing with customer who wants to develop, a certain type of product for the first time, it can be quite hard, to get all the relevant information from them in that case. So basically, and probably they won't be able like to provide to you, something specified in such kind of formalized form. So you will need like to get in touch with them to like throw out like meetings, and then write all those tasks by yourselves. And at the top level that there are like stakeholder requirements. Okay. So sometimes you will need to, write it down by yourself, get in touch with customers. Sometimes, customers will provide you stakeholder requirements through the, contract. So basically all big companies, I don't know, Porsche will give you like, 100 pages of document, and they will like have, thousands of requirements for a certain component, and that's it. You will sign that they'll implement all of them, and they will deliver, I don't know, like million of units, and that's it.